The chapter is heights and distances for standard 10, and this is part 3. Here the question: an aeroplane at an altitude of 200 meters observes the angle of depression of opposite points on the two banks of a river to be 45 and 60. Find the width of the river. So the aeroplane is at this height. So this is the aeroplane. So this is height is, let's write P and Q. Height is 200 meters. Observes the angle of depression of opposite points on the two banks of a river. So this is the river. So at this point, and from on the other side, so we will draw the horizontal. So this, let it be A and B. So this angle is 45 degrees and this is 60 degrees. So automatically this will become 45 and this will become 60. Now find the width of the river. Now we have to find AB. So PQ is given as, PQ is given as 200 meters. Now we have to find AB. So now we will take tan 60. Tan 60 is equal to opposite side by adjacent side. So PQ by BQ. So from this you will get tan 60 is equal to root 3 and PQ is 200. So 200 by BQ. So BQ is equal to 200 by root 3. Now we will take tan 45 is equal to opposite side by adjacent side. So again PQ by AQ. Tan 45 is 1 equal to PQ is 200 by AQ. Now we have to find the width of the river. So width of the river is equal to AB, that is equal to AQ plus BQ. So AQ will be 200 plus BQ will be 200 by root 3. So we will take 200 out. So 1 plus 1 by root 3. So this can be rationalized. So root 3 by 3, it will become root 3 by 3. So 200 plus 1 plus root 3 by 3, that is 1.73. So 2.73, 200 into 2.73 by 3. So you will get this as 315.4 meters. Now here two pillars of equal height and on either side of a road which is 100 meter wide. The angle of elevation of the top of the pillars are 60 degrees and 30 degrees at a point on the road between the pillars. So the pillars are of equal height. So let these be the pillars. This is the ground. This is the road. And the pillars are at 100 meters wide. So this is 100 meters. So suppose this is A and this is A, B and C and D. The angle of elevation of the top of the pillars are 60 and 30 degrees at a point on the road. So let that point be, that is this point be P. So from here, from here it is, from this point and from here. So one of them is 60 and one is 30. So from this point the two pillars are being viewed. So one is 60 and one 30. Find the position of the point between the pillars and height of each pillar. Now we have to find the distance AP and PC and also the height of the pillar. So let AP equal to, we know the total distance is 100. So let AP equal to x. Therefore PC is equal to 100 minus x meters. So now let this be h. Now we will take tan 60, because opposite side by adjacent side. So tan 60 is equal to h by AP. So tan 60 will be root 3. So AP is x. So this is x and this is 100 minus x. So AP is equal to tan 60 is root 3 is equal to h by x. Now tan 30 is equal to h by CP. So tan 30 is equal to 1 by root 3 is equal to h by 100 minus x. So these are two equations. So we will write h is equal to root 3x. So we will substitute 2 in 1. We will get 1 by root 3 is equal to root 3x by 100 minus x. So cross multiplying 100 minus x is equal to root 3x. So 4x is equal to 100, x is equal to 25, and CP is equal to 75. Now we have to find the height of the pillar. So h is equal to root 3 into x. So 25 root 3. So 25 into 1.732, you get this as 43.3 meters. So the position of the point between the pillars, that is the point P, is 25 meters from A. Point P is 25 meters from A. a person standing on the bank of a river observes that the angle of elevation of the top of a tree standing on opposite bank is 60 degrees. So, when he moves 40 meters away from the bank, he finds the angle of elevation to be 30 degrees. Find the height of the tree and the width of the river. So, let this be the width of the river. So, the person is standing at this point. So, the width of the river is this much. Yes. So, this is a tree. So, from here he is observing the angle of elevation of the top of the tree is 60 degrees. So, this is the river, this is A, B. When he moves 40 meters away from the bank. So, from here he is moving to this place, that is 40 meters. C, the angle of elevation is 30 degrees. Find the height of the tree and the width of the river. So, AB is the river. AB is the river and BD is the tree. Yeah. So, now we will take this as x and this as h. Width of the river, this is x meters, and height is h meters. Now, tan 60 is equal to h by x, that is in triangle ABD. So, tan 60 will be root 3. So, root 3 is equal to h by x. So, this is equation 1. And now, from C, so in triangle CBD, tan 30 is equal to h by opposite side by adjacent side. So, h by 40 plus x. This is equation 2. So, tan 30 is equal to 1 by root 3 is equal to h by 40 plus x. So, now substituting h is equal to root 3x. So, root 3h is equal to 40 plus x. So, h is equal to root 3x. So, root 3 into root 3x is equal to 40 plus x. So, 3x. So, this will become 2x is equal to 40 and x is equal to 20. It is somewhat similar to the previous problem. So, x is equal to 20 meters you get. Now, you have to find the height of the tree. So, h is equal to root 3 into x. So, root 20 root 3. So, 20 into 1.732. So, this is equal to 34.64 meters.